This is a mini project supplement over the T interval. Number one, the General Social Survey, GSS, collects data from a representative sample of adults in the US on the number of attitudes and behaviors. So I've given the link here. One of the questions asked as part of the survey is how many hours are spent watching TV on a typical day. Data set we're going to use consists of responses from a sample of 1,555 adults from a 2018 survey. These data could be used to estimate the mean number of hours spent watching TV on a typical day for the population of adults in the US. So we're going to go to StatCrunch here and open the data set. Now you can either follow along if I pasted the data set into the D2L, or you can sort of watch. Okay, so whenever we have raw data, we're going to go ahead and run a couple of visuals. So I'm going to go ahead and go to graph, and let's do a histogram. And I'm just going to take the defaults for now, see what we get. Okay, that's the distribution. That's kind of what I would expected, right skewed, and I also like looking at a box plot. So to go to graphs when I have a fairly large data set. Ooh, I like mine to be horizontal. So I'll flip that back over. And there we go. So I will often ask you to do screenshots of those. We could put those side by side and do a screenshot. No need here. Now let's go ahead and run a confidence interval. So we're going to go to stat. This is an interval for means. And so the mean is going to be the t stats, not proportion, t stats. We just have one sample and we have the raw data. Now if I had this data summarized where I had the n and the sample mean and standard deviation, I would do a summary. So with that, I only have one column here. That's pretty easy. Confidence interval. And I believe it is a 90%. Almost put 95. So 90%. If I miss it, that's where it's going to be. So 90%. So there we go. So there is our interval. We often will round these just to a couple places. So we could say 2.82 to 3.06. So part B, think about how you've previously interpreted confidence intervals for proportions. How would you interpret the confidence interval you just created? So we are 90% confident that the true mean number, not the sample mean, the true mean number, the population mean of hours adults in the US spend watching TV on a typical day is between 2.82 and 3.06 hours. So again, which of these is a correct interpretation of the confidence level 90%? So remember, our confidence is always about the method. We want to avoid words like probability in this point. That's not 90% of the US adults. It's the method we're used to construct the interval for many different samples from the population. About 90% of the intervals would contain the actual population mean. And again, let me show you again what this means. If I'm going to do a confidence interval, going here to an applet for a mean. So I want to simulate this real quick. Now recall, our sample has 1,500 or so. If I want to take another sample, likely is this going to occur? We're not 100% sure, right, that our sample is going to contain the true population mean. But if I took 100 samples, we would expect about 90 of those. In this case, this simulation, 88 of them contain the true population mean. I did this quite a bit in the chapter summary video, so I don't want to do too much more here, but that's what that confidence interval is about. It's about the process of taking and getting our interval. If you were to use this sample to create a 95% interval rather than 90% interval, how would the width of the two intervals compare? We did this quite a bit with proportions. Now we'll go ahead and run it, but mentally we ought to be able to know what that means, right? That the 95% is going to have to be wider than the 90%. And you can run this and see. So back over in StatCrunch, if I go to Options and Edit, and just change this from 90 to 95% and compute. Here we go. It's just slightly wider. Our sample size is so big that you can barely see it. 2.79 as opposed to 2.82, and 3.08 as opposed to 3.06. And actually, that's what part E asked you to do. And again, there are a few assumptions and conditions that need to be checked. And we did this quite a bit in the chapter summary videos. The two big ones are a random sample. This will almost always occur in textbooky type problems. Otherwise, we can't really move forward. So it's reasonable to regard the sample as if it were a random sample. Now, if you see that the way that the study got their sample was biased. We have to be really cautious about the intervals or any inference that they made from their sample. And then the other one is that the population, this is the big one here, needs to be approximately normal or the sample size is large. Now when we say large, we really mean anything more than 30. We saw this in the chapter summary videos that once we get a sample size over 30, the sampling distribution is relatively normal. And our sample size is huge, even though it was very right skewed. Since our sample size is 1,555 or so, we are good to go. So that condition is met. Okay, let's look at one more. Researchers in New York carried out a study to investigate how many calories are consumed when people eat lunch at fast food restaurants. They asked people eating lunch at different locations of McDonald's, Burger King, and Wendy's if they would give them the receipts after they had ordered. And then they used the receipts to see what had been ordered to determine the number of calories in the meals. A total of 3,857 meals were analyzed in the study, and the researchers believe the sample was representative of lunch meals eaten at fast food restaurants. The mean calorie count for the sample was 857 calories, and the sample standard deviation was 677. So is the one sample t-interval appropriate way to estimate the mean calorie content of fast food lunches? So yes, the one sample t-interval is appropriate. So we're regarding that sample as representative of the population, so it's random, and the sample size is pretty large. So now let's use StatCrunch to calculate a 95% confidence interval for the mean calorie content of fast food. And if we just had one number, we would say it's about 857 is the mean. But we know that there is some error. If I went out and got another sample of about 4,000, it's going to be slightly different. So what is that interval going to be? So I'm going to go to Stat, T-Stat. Don't go to Z-Stat. It'll give you something very, very close, but we're going to use T-Stat. It's just one sample, and this time we have the summary data. So recall the mean was 677, or sorry, the mean was 857, and the standard deviation is the 677. And the sample size was 3,857. And confidence interval, and we are doing 95%. And press compute, and we're going to get interval from about 835.6 to 878.4. So imagine the next question is how to interpret. So I am 95% confident that the true mean or the actual mean calorie content or the population mean calorie content of fast food lunches is between 835.6 and 878.4. Whoop, got a little typo there. Calories. So the last part, an article, website Global News, included the following statement. Although every person's daily caloric intake is individual, based on personal goals and needs and nutrition, experts estimate the average daily consumption at each meal should be broken down as follows. 300 to 400 calories for breakfast, 500 to 700 for lunch and dinner, and snacks shouldn't exceed 200 calories. Do you think that your confidence interval for part B provides evidence that the mean calorie content of fast food lunches does not meet the recommendations given? Well, notice that both our endpoints are above that high end of the recommended range of 700 calories. So the interval does provide evidence that the mean calorie content of fast food lunches does not meet the recommendations in this quote. Okay, so I hope that helps.